Welcome everybody to the Sarah Drake's Lounge. The couple announcements. One is thank you everybody for the Western Conference. Um, uh, Dave Westman, Bob, and Nathan, I think, were the big hits on those. Uh, so that really went well. They got to see the eclipse through the clouds, and I think it all worked pretty well. The Uh, all of the videos were posted the next 2 days after the Western Conference. So if you haven't seen them on YouTube, go look there. Also, Nathan, I don't know if you know, but you went viral on your video. And I think you've got more hits than Wolfgang and Alex did on theirs.
Oh, oh,
And I'm not
really?
sure why. You're just very popular looking guy, I guess, huh?
Well, it's not because of my looks, I can tell you that.
No, it didn't hurt. So,
It was dark enough. But actually, I don't know if anybody saw, but it was, I think somebody from Hackaday.com caught wind of it, and they actually made a post about that. And I think that may have spread the word out quite a bit more.
excellent. Well, we'll take it. And
Yeah, I'm really excited. Hopefully, it increases the number of people that want to get into the hobby. So,
oh yeah, yeah, I think it worked well. Let's see. Let's see. Okay, we did. The journal has been sent out. So if you did not get the link to the journal, let me know. So it should have gone out to all paid members. And and one other correction on the journal that someone noted was for the Eastern Conference. I think the journal says 250 for the cost of the conference, and it's really 275. I got to go look at that again. So if you're thinking about going to the Eastern Conference, there is there was a price change that didn't get into the journal by an extra $25 or something. So that's if you're attending, I believe. Yeah, if you're not attending, then it's a standard online rate, which is probably 10 or $20. So that'll work. Okay. Uh, Ted, you got anything?
Excuse me, you caught me mid-orange here. No big news here. Ezra is still alive. I'm still poking away at it, but you have no proof because I haven't posted it. I thought perhaps we're collecting data. Why not make a an RFI environment study where you actually walk up and down the frequencies and make a bigger view of the frequencies nearby? And trying to zoom in on certain parts of the sky, improvements like that. So coming attractions.
Yeah, I'm really intrigued about the work that I think it was Jason was doing with the Andromeda galaxy, the high Doppler shifted galaxies that they could see about, instead of your normal hydrogen, it's up a little higher frequency because they're moving toward us. Um, that would be very interesting to get on Ezra and see if we can see any galaxies.
Exciting work. Yeah. Well done,
Okay.
Jason.
Uh, let's see. Um, Preston, you had some solar eclipse video or pictures.
Okay, I'll let's see if I can do this. I don't know. Oh, there we go. Here's one. And you can see the prominences are, I guess, orange or red. There's one there, one up there, I think, and one down there. I think this little gap in the corona is probably where a cloud is trying to creep in there. But that's one of them. Any questions about that one? Okay. Let's see. Yeah. Y'all could see that all right, right?
Oh yeah. I think the
Okay.
questions that are going to come up is what did you use? What kind of camera, filters, all that kind of stuff did you use to get that?
Okay. We'll do that in a minute. I'll bring up the other one if I can. Let's see. All right. The other one's over here. And this one, you don't see the prominences, but it's just at a little different exposure. So you see a little more of the corona. Okay. Yeah. Have to find the, stop share. There we go. Okay, so I'm back. Yeah, I used a Canon R6 and I used a 100 to 500 telephoto zoom, and I was at 500, and then I cropped it at 300 dots per inch, photos about 20 inches wide with the R6, and I cropped it down to 10 by 10, which gives it about another 2 to 1, or another factor of 2 apparent magnification. So any questions about that? Oh, and the filters, I had an ND filter, and it said ND, it said 100,000, but I'm assuming that's how much it cut the light, not the actual ND number. It wasn't a real expensive one. So, and last time we were all in a Zoom meeting, Alex recommended I get a infrared and ultraviolet cut filter, and that was on there as well. So I did get one. So didn't want to fry my camera. So anyway, I did see a thing on cameras that somebody did an experiment just to see what would happen if they pointed their telephoto at the sun with no filters, and within 30 seconds it was smoking. They used one of their older cameras as an experiment. So any questions?
Just like burning ants on a sidewalk when you were a kid. You do the same thing to the CCD.
Yes, exactly. But he wanted to prove it, so he did.
Did what was the experience where you're on the University of Texas Dallas campus? You were surrounded by a bunch of 1,000 students or something like that, and all that kind of stuff. But so sort of tell the story or the adventure of getting this thing.
Well, it was really great being out there with the students, because they reacted to everything. Every time a cloud would cover the sun, they'd boo and stuff. And then when the total occurred, they booed because the sun was gone, and then they cheered when it came back out. So they were very reactive and emotional, and it really was neat. I had never seen a total eclipse before. So during the part before it became total, I'd seen lots of partials. So I thought, oh, well, it's just another eclipse. But I tell you, when it reached total, I really, really felt it. You know, I could feel it. It was an emotional thing. So it's like, wow, you know, so it was really a good experience.
It's eerie because it's like you're in a dark hole, because as you look around the horizon, it's still light. It's very strange, isn't it?
Well, I was surrounded by buildings, so I didn't look far. And the students, every time I looked away from my camera, I looked at the students because it was just interesting to see how everybody was reacting.
Yeah, the thing that always struck me about it, because I saw the one in 2017 as well in Kentucky, but the thing that struck me so much is how rapid the change is and how drastic the change is when it goes from 99.9% to totality. And
Yes.
it's like literally like somebody takes the fader in the sky and pulls it down in 5 seconds. You know, it's just like crazy.
Yeah, all the dawn to dusk lights come on, and it's awake, and there's still some light there, I guess, coming from the corona, but it's kind of eerie, like. So, to me, it was.
All right. Well, hey, thanks. Excellent work. Bob,
Thank you.
you're sort of the hero of the Western Conference, being able to take that on since David couldn't make it. But what's your experiences and what'd you think?
Oh, I wasn't a hero. Nathan helped a lot. It was very helpful to have him operating his computer and running the Zoom, and everything did work out pretty well in the long run. Would have been better if we didn't quite have the cloud cover that we had. I mean, it was pretty cool out there, and sort of threatening rain, but it didn't rain. I just quickly, I didn't prepare for this very well, but let me try to share my screen and see if I can show you some pictures that I took. Let's see how they turn out here. They might not be large enough. Can you see these pictures on my email here?
On the right, yeah.
Okay. So one of the things I wanted to do is sort of like take a panorama at the time of the eclipse. And I did that, and the iPhone didn't do it justice because it adjusted very well for the brightness in the sky, but it got really pretty dark.
Hey, Bob?
Yes.
Are you trying to point at a picture now? Because we're not seeing what you're pointing at. It looks like you're part of your email chain.
It
It's
is
like
an
three.
email. I'm like flipping the pictures up. Are they going up
It's
on?
three
No.
you see three columns. There's like a directory on the side, and in the center it says Bob Strickland's Sour Groups, and then on the right side are small, large postage stamp photos.
Okay,
We're not seeing the whole-
I tried to share my desktop, and I thought that the email would pop up on the top. Did it help? I'm still not where I need to be, right?
No. Can you click on the photo?
Let's try a different way here. Let's try it like this. How about that? Did that come up right?
It's mostly a white screen, and now the pictures are on the left.
Right, and they're not very big. I know they're not, but are they big enough for you to
Okay.
get a feel
You
for the
can-
brightness?
Can you
I
zoom
think
in?
you can zoom out on those pictures
Uh,
or zoom in. There you go.
Zoom in. There you go. Yeah.
There you go. That works.
okay. I just tried to snap the sun up there, but then you see all the kids were all in this courtyard here, and they're all looking up, and you get a feel for how dark it got by just looking at the lighting in the building. But the camera the iPhone will automatically adjust to try to improve the brightness. This is Robert Lucas right here, and he didn't sort of stop to stare at the eclipse like all these people were. He kept focused on his efforts to take pictures and things. Look how this young fella's phone has lit up his face here. It gives you a better feel for how dark it really was there at that time. And this is looking back around the side. The kids and people were all down this hillside, and there was like a slope there. And that's where we brought our equipment in. There was essentially it was like a sidewalk that they allowed us to drive down and unload, which was a real big blessing. And who was it that set up a radio telescope a small itty bitty telescope and had it running down there on the side, and the kids would come around and ask questions and ask if they could help you with setup. And I did have a few of them helping me on occasion, but everybody was looking up. And this is a good one of Robert Lucas here, focusing his equipment, trying to get things running. You can see his computer running down here on the side. And this essentially was just kind of like where we were. We had our equipment strung out here and standing here looking, and it was just packed in. You know, when I first scoped out this area, I was hoping we were going to get one of these tables, but by the time we got outside and started thinking about getting a table, they were all taken. You know, this all really got started pretty early and lasted for probably a couple of hours, I'd say. There was a radio station over on the side too, playing music and interviewing teachers constantly. I don't think I got my camera. Yeah, you can see this little tent right here. And they had some big speakers there, and they were playing a lot of music and stuff. And they'd have a teacher come up and interview them about what they were hoping to learn from the Eclipse. And several teachers had, professors had experiments set up. And one of them we talked to, Rodriguez, told us later that right after the Eclipse was over, somebody came up to him and said, "What did you learn?" You know, right away wanted them to explain what they got out of it. And of course, he needed time to analyze his data, but he could see in his data right away that some interesting things happened that he didn't anticipate. But let's see. Anyway, that's kind of a snapshot of that. What I'd like to do is come back, if you don't mind, come back to me in a few minutes. Let me bring up another picture and show you something that I copied here locally on my radio equipment. Okay. I'll have to find that, make that.
Okay. Nathan.
Yes,
Mr.
sir.
Mr. I am viral internet.
I reckon. I don't know about that, but no, the Eclipse was fun. The conference was a lot of fun. Bob put a lot of work and effort into it, even though the signs got ripped up and thrown away before they were in use. But yeah, it was really great to meet a lot of the people, a lot of the faces I see here, like Preston and Bruce and all those guys. It was just it was really fun. A lot of interesting conversations. A lot of interesting ideas came out of this too. Some stuff that I'm starting to think on and starting to work on now, just as from an educational point of view. So just starting to get ideas for more projects. So hopefully when I get a break from work here and I get my telescope repaired, then I'll be back in business and I can start collecting data again and then start working on the 20 meter stuff, because I'm still trying to work on programming for that. Still trying to make improvements for Ezra for tracking, and just trying to stay busy and hoping we get more people involved and people that want to learn about the science.
Well, thanks for your help. You just like you handled that conference with the Zoom perfectly. That's a lot of coordination there, and it worked great from an online point of view. From my view, it just went smooth.
Yeah, it could have gone smoother. I do a whole lot of online meetings for work and everything, and have been for years. So it's that practice has really paid off, I guess. But it's also got me thinking of something we can do for equipment. Maybe I'll put together an idea and pitch it to you guys and see some sort of like standard Sarah conference web software package or hardware package or something, so that just makes it easier on everybody.
Well, great. We'll take all new ideas. Let's see. Who else went to the conference? Was Jason? Did you go? I forget.
No, I actually I thought about attending remotely, but my laptop was tied up doing a drift scan of the sun, so with my dish. So,
Good excuse. Good excuse.
and
Uh, well,
will present those when it's my turn. So,
okay. Well, I'll make it your turn now. Go ahead.
okay. So I'm gonna do. Let's see. Where is it? Share my screen here. Here we go. Share screen. Okay. All right. So let's do, I'm just going to do this. Come on. There we go. Not sure where to put this. Maybe I'll do that. Okay, there we go. All right. So we were I'm in Bloomington, Indiana, and we were right in the center of the totality track. So it was perfect. I set up my dish in my driveway, and I was wearing my Dark Island Shadow tartan kilt. So I thought that was kind of appropriate. And I did celebrate totality with a single malt scotch. I used my homemade protractor and a plumb line to set my elevation. And then I did use Ted's Easy Coal data collection utility from Ezra for my total power scan. And then what I did, there's a picture during totality, and yeah, it's super dark. This is the raw drift scan from the actual day of the eclipse. I didn't get my azimuth setting exactly right. I was a little bit to the left, so I was trying to put my peak in the center of totality, and I was a little off, but then I did a reference scan the next day. I left it set up at exactly the same place, and then I did a comparison between the two. And here's it flattened it out, and so here's my total power eclipse versus reference. And one thing I noticed is really strange. The dip the deepest part of the dip, and I double and triple checked the timestamps. It was 2 minutes early, and I'm not sure why that is. I don't know if anybody has any ideas there. I'm wondering if there was some kind of diffraction effect happening at the 21 centimeter wavelength that caused it to reach basically the minimum earlier than actual optical totality. It was just strange. I'm not sure why that was. And then the other thing that I
Could it
noticed,
be that the system was acting differently in the dark? It was cooled off and working better after the eclipse. Therefore, you'd get more gain.
that could be. And I getting kind of that would make sense. So kind of in that vein, I wonder if it one of the ideas I had was I did stabilize the temperature on my SDR by just thermally bonding it to a giant heat sink. And that did help with stability. But I think if I could wrap some copper tubing around the case of my LNA and run some flexible line to it and run a little water pump from a 5-gallon bucket of ice water, that might temperature stabilize it. and keep things a lot more stable. Because what I'm trying to do with these hydrogen line observations of extragalactic sources is, I'm getting down to where I'm kind of rolling dice with the stability of the system long term. And so usually I get a decent scan, but sometimes some days I'll get one that drifts too much and it's not flat enough, and I have to toss it out because it screws up my data set. So that's an ongoing thing. So the other thing I've done since last meeting is I've gotten my cake pan loop feed working and tested against. I basically just compared its performance against my other feed that I knew was at least working well, I knew its performance was good enough for what I was doing, and I did several tests, and pretty much the loop feed was working as well or slightly better than my other feeds. So I actually switched over to using it because it's just smaller and it's lighter. So then the other thing I did is I continued doing additional drift scans of M31 and M33 and adding that data to the overall average. So I've got up to 2.5 hours of total integration time on both of those. And so here's the M31 blue shifted peak. The top is the reference profile, and the bottom is my 5 days worth of data averaged. And then this is M33, same thing, reference scan on top and my data on the bottom. So yeah, I'm pretty pleased with the results. I did discover after I submitted my presentation to the journal that I had made a mistake in my VLSR corrections, and so my frequency bins were slightly off. So I don't know if you notice on the plots on my presentation that was published in the journal, the peaks are shifted to the left a bit because my velocity bins were off because my math I added instead of subtracting. I got my sign wrong, so I corrected that in this, and it's now correct. So the next thing that I'm going to tackle, there was a paper that was cited in J.J. Manto's paper that was a 1975 survey of several nearby galaxies in the hydrogen line, and including M31 and M33. And I noticed that the next one in line as far as brightness is M101, and it's about an order of magnitude weaker of a signal than M33 or than M31. But I think it may be pushing it, but I'm going to see what happens. I'm going to spend some time on that and see if I can get anything to emerge. So this is what the profile looks like. Let me see if I can get this banner out of the way here. I'm not.
We see no banner. It looks great.
Okay. So good. So yeah, this is straight out of that paper, the 1975 survey. And so M101 is my next acquisition. I'm going to try it, see if I can push it to that limit. It's like I said, it's, M33 is at around 50 Janskis, and the top of the peak on this one is 16. So we're getting down to where it may be beyond the limit, beyond the performance capability of my dish. But no harm in trying. So I figure if I spend enough time on it, I might get the noise down enough to at least see the high peak. Now this one, interestingly enough, M31 and M33 are in our local neighborhood, so they're actually blue shifted because they're actually moving towards us. But most galaxies, obviously, once you get out of the local neighborhood, are receding. And so this one is redshifted. So it's it's redshifted well outside of, again, well outside of the local hydrogen signal realm. So we don't have to worry about any interference from the local hydrogen line signal. And then this is just the reference for that paper that I got the M101 profile from. And there are several others in the tens to low teens of Janskis. So if I can get down to, double digit, low double digit detections, there may be a couple of others that I can get, but then once I get past those, it'll be beyond the capability of the dish that I have. But anyway, it's just that's kind of my next thought, or my next project, is to try to bag M101. There is an interesting personal connection with M101 in that I was inspired as a kid by the Madeline L'Engle novel A Wrinkle in Time, and M101 was the location of one of the planets that they stopped off on at the beginning of their journey. So I thought that would be kind of cool to have a literary connection to an object I'm looking at. So but that's all I got for today.
That's great work. And let me make you an offer. You get this one figured out, and the DSES 60-foot dish, we can arrange for you. If you want to come down to Haswell, Colorado, you can plug your equipment into that and use a 60-foot tracking dish. And that would, because it's all set up so you can just plug whatever receivers you got, whatever computers, right into the dish.
Oh wow!
At 1420, and you can track as long as you want with a 60-foot dish. So think about that.
Yeah, that definitely might be something I'd be interested in the future. Is
Yeah.
One of the other things that I plan to do in the near term is document in more detail the the mechanical design and the materials of my portable dish, and make those accessible to the community if somebody wants to be able to duplicate that. Because now that I've kind of gotten it to where I'm fairly happy with its performance, both usability wise and the performance of it, it's definitely something that would be accessible. I mean, everything except the Faraday fabric I literally purchased at Menards. So, and the only tools I needed was a hand drill and a bandsaw. So I mean, it's very accessible to people who don't have a lot of money or means. So, but anyway, so
Well,
that's all I got for today.
excellent work.
Thanks.
Bob, did you want to come back on, or
Sure. I need to let him stop sharing. It's at the top, Jason, of the screen. There's a button for stop. Do I have my audio on?
yes?
Okay.
Oh wait, are we supposed to hear something from the? I don't hear anything but your voice.
No, just for me talking. So this is a graph of I'm listening here on 10 megahertz. This is monitoring WWV essentially. And you're seeing my screen too properly, right? Okay. So you can see here where the signal strength is strong, and this is during the nighttime. So what we have here is time of day in UTC time. So the signal is strong, it's deep red. And then always when the sun comes up, the ionosphere starts to load up with electrons, I believe, and stop propagating signals well. And so it takes this dip, and then it floats along during the daytime hours. And then here comes the eclipse starting to happen. And this is the actual eclipse. It causes this big swing in the propagation. And what this is the hertz of shift in the signal that I'm seeing from WWV as a result of changes in the ionosphere. And this is part of the HAMSI project, actually. And I've got two stations.
Hey, Bob.
Yes.
We're seeing your screen with a green.
Yes.
And then underneath is a blue. Is that what you're pointing at?
Yes.
Okay.
My mouse
right.
going up. Right.
Yeah. Make sure it's showing up. Okay. Okay.
Okay. So what's interesting to me, you know, I've been thinking about this more lately. See, we're doing this 724, and I've been doing it for 6 to 8 months now. So I've got data like this for every day. And then the eclipse was just a special event to have this big dip happen. But look at 3 or 4 hours before the eclipse, propagation picked up again through the HF band. So if you were working the radio, you should have had good propagation prior to the eclipse. And my theory right now is that's because the eclipse started much earlier south of me and worked its way across the United States. So it was affecting the ionosphere. And so if you look at it, you can think of it like this too. This sunrise that I'm experiencing is traveling around the world. So always the ionosphere is going to be influenced by the sun on a sort of a rolling manner as it goes around, as the Earth rotates around. So there are people doing lots of research on this data. So if I look at the home on this website, this is the Personal Space Weather Station website. Now I'll put this in the chat in case somebody wants to try to look at it. You can see all of the different stations that have been collecting data. And so my station is right in this area. If they're in red, they haven't checked in for quite a while. And if they're in yellow, they hadn't checked in for 2 or 3 days. So there's data like this from across the United States that was accumulated to try to do a sort of a 3D map of the propagation through the atmosphere, through the ionosphere. Okay, and so in this data, you can do things like filter on a particular station, and they're also monitoring multiple frequencies. I'm only listening on 10 megahertz, but there are people that are using software and SDRs that are capable of wider bandwidth. Some very interesting things that could be applicable to radio astronomy later if you want to try to monitor like 100 megahertz bandwidth, for instance, on some other frequency using a transverter. Okay, so I'll stop sharing. Any questions about that?
That's really good. And anybody what HAMSI is a very it's almost like a sister organization. We can see a lot of their stuff. We present a lot at their HAMSI conferences every year. So if you don't belong to HAMSI, that'd be a good thing to do. And this personal weather station things are really good. Okay, thanks, Bob. Skip Crilly.
Yeah, does everybody hear me okay?
Yep.
Okay, let me just try the video here. Start the video. Yeah, so I've got a kind of a fun story to tell here. This has been an interesting week for me because those of you who, were at Green Bank during the summer heard about this interferometer that I was building. And I'm using it for SETI. I've been looking at this location in the skies for about 6 years now, near Rigel. And I was talking at the conference last summer about the use of the interferometer to measure the same direction in the sky. And it all started with Rich and me kind of thinking about using the 60-foot and the 40-foot in tandem and synchronized. And that turned into a lot of fun. But anyway, I'll tell you the quick story. And of this week. So I finished the observations that I was doing for 61 days using the interferometer, and the Rigel direction pops out of the data pretty strongly. Again, with these narrowband pulses that I've been looking for. And so I wrote a paper on it, spent a couple of months working on the paper, and the paper was accepted. So are you all familiar with arXiv? So let me see if this shows up.
Yeah, it looks good.
Is that showing up? Yeah, arXiv, right?
We'll put it in the chat link.
Yeah, does everybody know what arXiv is? So maybe a show of hands or something, maybe.
Well, I don't. I'd like to know.
Yeah, ARXIV is a Cornell University database of scientific preprint papers. So this is someone who wants to publish can submit a paper, scientific paper, and it's moderated but not refereed. So the moderators are technical people and familiar with the journals, and they pretty much know what could be accepted for a journal. And so they will decide then to pick something, whether it be physics or biology, and there's a lot of different fields. There's about 2 million preprint documents in the database. It's been running for quite some time. And that's where I've placed 5 papers now on this strange direction near Rigel. Well, it turned out I turned in the paper, and about a day later, it was approved and it was accepted, and it showed up in the categories that I had chosen, which were electrical engineering, signal processing, and astrophysics instrumentation and measurement. So that paper, I thought, okay, well, that's great. Now I go on and I'll start working on the next paper, and I want to make some improvements on the dish and dishes that I have. There's 2 8-foot dishes in the interferometer that I run. So it was a day later, I think it was, maybe the next day, that I noticed that someone at arXiv decided that the paper should be placed into another category, which they have the power to do. They can basically take the categories that I choose and add a category. And they added popular physics to my paper. Okay. So now the strange thing about popular physics is that popular physics is the arXiv category that has, let me see if this works. So there's arXiv and there's popular physics. And there are not very many papers that show up in arXiv. But it turns out that the paper that I wrote is, as of today, does that say interferometer?
Too high, a little lower.
Maybe it's, okay, 1, 2, 3. Well, I think that's it right there. Yep, there it is. So it turns out it's the 3rd paper now in popular physics in arXiv. Well, they receive about 2,500 physics papers a month. This is for this month right now. There's only about 10 papers that they've decided to place in popular physics. I don't think that individuals can choose popular physics, but for some reason, they decided to take my paper and put it in popular physics. So, I don't know what's going to happen as a result of that, but and maybe they take things that are, it appears that sometimes if something is quite far-fetched, perhaps something that is someone's idea, as opposed to, an experiment that was performed, then they put it in popular physics. So I can imagine that could happen. But anyway, So the paper is in there, and I don't know what's going to happen as a result of it, because that wasn't something that I was planning to do. But I don't really have any thing going on my machine here to be able to show you anything. But I suppose if you want to read the paper, you can just archive popular physics, Google this. If you just Google that, and then you can see the paper. It'll be on that page there. And yeah, and I appreciate it. I don't want to take a lot of time in presentations and such right now or anything like that. But if anyone wants to look at it and take a look at it and see, I'd really appreciate the feedback and the ideas, and whatever thoughts you've got about these measurements that I made. So yeah, okay. Well, I guess that's about it. Thanks, Rich.
Oh, thanks, Skip. This is good stuff. Anybody got any questions for Skip? He's an excellent interferometer guy. So if any interferometry questions. No? Okay.
Just and just one other thing I just wanted to say, just finally, is that the acknowledgments in the paper. So I guess I don't know if you can see it in there, but so Sarah. So I guess the headline is Sarah has been acknowledged in a paper that's in Archive Popular Physics this month.
Excellent. We'll take it. Thank you.
Okay, you're welcome. Thank you.
All right. Alex.
Good afternoon. I have a very short slide set and just a teaser into what I've really been doing the past several months. Let's see something. Let me show you this. Maybe. Can you see the presentation?
Yes.
Okay. Little history. I've been doing this. I've had a similar setup or variations on it for the past 3 years, where I set up the tripod and telescope. It's about 60, 75 feet away from the computer. The standard configuration's been the telescope with the LNA, and then about 8 meters, 25 feet of coax to a remote SDR. And for the past couple of years, that had contained the USB to a Cat5 cable connection in here, and that works. It's noisy. The Cat5 cable is not used in a balanced configuration, and so it radiates. And it's bulky. The 25 feet I've used LMR 400, and I've always wanted to go with fiber optics just for the novelty of it. And so I did on these disc Yagis that I've been developing. I used this box at the telescope where I could run fiber optic all the way. And I discovered an issue that I have had to some extent for quite a while now. In that the SDR is in here. In the past, I had the SDR, like I said, it was 25 feet away on the porch, on the patio, concrete, typically covered to keep sun off of everything. And it has shown some variations, but I never could really identify it. I attributed it to changes in sky or maybe reflections of heat off of the trees, which are abundant. But the first case here was non-fan cooled. I had the SDR connected to an angle bracket to the chassis. And I started, even without the sun on it, I had a lot of internal heating, and I was getting huge spectral shifts, which I had never identified before. The SDRs change spectrum sensitivity with frequency, not just amplitude. So this shows, whoops, that didn't work. So I added fans. but I also changed the inside from the angle bracket to about 4 variations of heatsink. That kind of worked, but I was still at the mercy of cold mornings and hot afternoons that I couldn't control. So the next step on this was this. I'll show you what the inside looks like, but to use an active control system of the temperature on the SDR. This is a neat little fan control switch. And what I'm doing now is setting a set point which is a little bit higher than the ambient temperature. So this thing will always be maintained in a warm state. This thing really works well. Set it for like 40 C and 2 degrees Delta, 4 degrees Fahrenheit, and it controls well. So I've been using 3.5 watts of resistive heat on the heatsink, and then fans to cool the box. The other interesting thing it identified on the Air Spy is its heat transfer path is through the SMA connector, not really through the chassis. The heat comes from here, goes through this panel, and then into the case. So there was a lot of work on this. I mean, I've done a lot of tests to identify this, and this is actually working pretty well. In that this is a 24-hour period, and I'm pretty much flatlining the spectrum shift. There are some level shifts. This is interesting, and I've had these shifts and I've never identified them. They were never as significant as this because the box was never in sunlight. It was sort of just by chance controlled by being near a piece of on the ground, on the concrete backyard slab. But as the day went by, I'm not sure why it started high, but it maintained a level here for a period of time. And then in these times where the little styrofoam plastic I had protecting the sun from the box became unshielded and got some sunlight on it, were some shifts. But this was at a 95 Fahrenheit control point. I went up to 105, so hopefully I can maintain that internal temperature, and we'll see if this stabilizes. The box has gotten really busy. It was bad to start with, but the fiber optic interface is here. It's large. This box should have been built larger, but there's a fiber optic here, box transceiver here, the SDR here. This is a bias T to feed the no electric LNA. Here's the little temperature controller. The resistors go into this heat sink that are buried under here. This box is full. So that's been the short. The long version is I have been testing, I modeled and tested this. And this is a rectangular patch Yagi, and I can build these things. These take about 1/10 the time of the discs. And so this is a feasible potential antenna that can be sold for $50. But that's a future presentation. I'm putting a large, maybe a 50 slide presentation that I'm just going to PDF because I also have several slides on modeling. I think there are some people that are not familiar with NEC modeling, and I want to at least show the highlights of not how to use it, but what can be done with it. So that's the story. Any questions?
I don't have a question, but I would comment maybe on your SDR. You could maybe stabilize it better by using a good or a better reference oscillator. The one that you showed doesn't seem to have an input separate, but I think you can get to it. But there is another Air Spy that has an external input for a LO, and you could get a Leo Bogner GPS discipline reference and set it at whatever frequency you needed to make the thing stay on frequency better.
Whoops, you think it's
I think he's saying the frequency is stable. It's just that
the
its
spectrum
pattern
changes.
changes.
There's There's a shift in the spectrum response.
You don't think that's due to your LO moving with temperature?
I don't know, but there's no way I can fit all that in a remote box. The simple solution is just what I'm doing, just temperature control it and call it solved. I don't know, Bob.
Okay.
Uh,
I thought I'd mention that.
Let me think about this for a couple seconds. No, I don't. No, it is not. It isn't the. It's not the frequency shifting because. Let's see, I dropped some slides out of here because in my processing, all I do is level shift, and I get good drift scans. Let me. Hold on a second. Let me see if I can find something quickly. I don't know. Let's see. I'll tell you what. You want to let someone else chat, and let me bring up another slide to show you what I use for processing, and it's not a shift in frequencies. So let me let me slide.
Hey, Alex, I got a question for you. So your thermal stability of the LNA doesn't seem to be as sensitive. That was surprising to me because I found the same thing when I was trying to detect for galactics.
Go look on the Sarah zooms. I did a full presentation on that. The number that I came up with, and then I actually found data sheets on the FETs, is a tenth of a degree minus 0.1 degree change in gain per 10 degrees C, plus 10 degrees C. Very small. It's not gain. It's not gain.
Yeah.
I did a video on that.
Okay. Yeah. So somehow it's the receiver itself that's drifting all over the place because of temperature variations.
Okay. Well, let me, while Alex is working on that, let me go to James Thompson.
Hello, can you hear me?
Yes.
Good, good. So I guess a couple of months ago, I had an old Radio Jove kit, an old one that was sitting around. I had never put it together. So I decided maybe I would put it together and set it up to do some solar observations during the eclipse. Well, I got the kit put together and it seems to work fine, but didn't have time to get the antenna up. So I never got any observations with that. As far as the eclipse, I was able to go to Cuyahoga Valley National Park in Ohio to see the total eclipse. And I got a couple of pictures that might be interesting. One is just taken with my cell phone, and it really isn't that special. The other one, I took a picture of the, actually, let me see if I can share this. Yeah, let's see. Not sure which screen I'm supposed to share here. One moment. Okay, there we go. I think that's the one. No, that's not the one.
Or now you just go to the desktop.
Yeah, there we go. There we go. Hold on. All right. Can you see that?
Yep.
Okay. So that was the picture I took of the total eclipse. It's overexposed. I just took it with my cell phone. Could have been better. There were some people nearby. The park was filled, by the way. There were no parking spaces anywhere. It was just like a big party. So that was the picture I took. The other one I took was of the partial phase after after the total eclipse. And we had some really light, wispy clouds passing through, but you really didn't affect the viewing very much. So hopefully you can see that. You can see the sunspot here, which this one actually came out pretty good. This was taken through an Edmund Astroscan. I'm just holding the cell phone up to the eyepiece. I did use a solar filter, of course, and that one came out pretty good. One other thing I'd like to ask everyone that was able to see the total eclipse is if anyone was able to see shadow bands on the ground just before or just after the total eclipse. In 2017, I saw that total eclipse in Greenville, South Carolina, and I had been aware of the possibility of seeing shadow bands, which right before and right after the eclipse, apparently the light, it's not clear whether it's diffracted or around the edge of the moon, or whether it's refracted in the atmosphere, or maybe a combination of both. But sometimes you'll see these shadowy bands moving across the ground, little streaks of dark and light that kind of shimmer on the ground. We saw them in 2017, but did not see them here on the 2024 eclipse. And I was wondering if anybody was able to see shadow bands.
We did not see them because of the clouds, I think. Let me mention to you what we did notice, and you might have seen this too, is right at the close to the time of the eclipse, we could see a planet just a few degrees off of the sun, and I think it was Venus. And it came through, it's kind of like a nighttime view of the moon almost, because you could see stuff around it.
Yeah, we were able to see Jupiter and I guess Saturn. I don't, or maybe it was Venus. I can't remember which ones we saw now. Apparently Mercury, we did not see that one for some reason. It could have been because of the clouds. We did have some very, like I say, some very light clouds. But we did see a couple of the planets.
If you care, from clear skies in Indiana, western Indiana, sure enough, Venus and Jupiter were bright. We couldn't see the Devil Comet nor any other planets.
Yeah,
I know about the shadow banding, saw it in 17, but did not see it this time. I was trying to find it with clear skies.
Okay, good.
Yeah, same here for Bloomington, Indiana. It was same observations.
Okay, interesting. Well, I understand
Jason,
it.
I wasn't very far away in Odin. Okay.
Yeah, I understand the
Is
shadow
that
bands are
Ted?
not always seen. So
Who was it that was in Odin? Sorry, I didn't have my.
Ted Klein in Odin.
Okay, I thought it was Ted. Yeah, cool. Yeah, maybe one of these days we'll meet in person. I do have some questions for you, by the way, at some point, concerning the Easy Collection utility. So,
let's talk afterward. This is fun though. Pretty picture.
thanks. And that's about it. I'll stop sharing here and turn it back to Rich.
That looks really good. Thank you. Let's see. Helen.
Can you hear me?
Yes.
Oh, okay. No, I was disappointed I missed the eclipse. I was scheduled to have medical work that week. But what really disappointed me was I have family in Corsicana and Maine, and I had nice invitations to go to either place to see the eclipse, and I just wasn't able to. But in Maine, the pictures that we got back, I mean, they were fantastic. The ones from Texas was okay. but it had just snowed a night before or 2 nights before in Maine, and the air was just so cold and so crisp that the pictures just jumped out at you. I don't have any pictures here, but eventually I can get them together because we're going to get the camera on my computer actually up and running when somebody's not working and can help me because I'm in a wheelchair, so it's difficult for me to do a lot of the stuff, and I need help. And I do have help scheduled, so we'll be able to do all that. But was able, a long time ago, to see a near total eclipse, and that was absolutely fascinating. And I remember one of the main things where we were looking up and my grandfather goes, "Now look down." And we looked down and all the spiders and the bugs and everything that come out at us were just racing out. And I would never even think to look at that. I had a cousin who was really into entomology. So while we were all looking up, he was looking down, but it's an experience that still, even after all these years, I could still remember. So I would have loved to have seen this eclipse, but well, it just didn't work out this time. But there's another one in a couple of years, so I could always go for that.
All right. Well, thanks. Hope you're doing better.
Okay, yeah, I will. Thank you.
Okay. Blair.
Can I be heard now?
You're great.
Very good. My astronomy group all went to the eclipse. I had a flat tire, so I had to stay behind, which wasn't bad in New Jersey. We were at 95% totality, so it was still quite a show. What I did is I participated in the Hamsci. Thank you, Bob. In the Hamsci QSO Eclipse QSO party. And I got on the air for the hour before quasi-totality all the way through to an hour afterwards, making as many contacts as I could, knowing that there was a pretty good chance that what I was sending and receiving was being picked up by the folks who monitor that kind of thing as part of Hamsci. I remember back in 2017, the operating hypothesis was that the ionosphere was too big and too dynamic to be affected by an eclipse, and we've been totally wrong. So I'll be interested to see what the guys at MIT come up with this time from the data that we all put out there. And that's it. I have no lovely pictures to show because I was only at 95%. Back to you, Rich.
Right. Thank you. Jeff.
All right, there I am. Yeah, unfortunately, I had plans to make it down to Texas, but unfortunately, my dad was in the hospital, and he had just gotten out a couple days beforehand. My sister was helping him in assisted living, and so I decided to go up, spend a week up there. So I didn't. My plans to go down to Texas didn't work out, but I watched it with my dad on the Weather Channel, and we watched it from way down in, where was it, Mazatlan, I think, and we got to see it, happen every time as it went to where all the Weather Channel people were all across the United States. So it was kind of fun, it's like, okay, I didn't get to see it in person like I did in 2017 with my son, but I got to spend it, watching it over and over again, for a couple of hours on the Weather Channel. So it was a good experience to be able to, spend some time with my dad and see it that way. So that's pretty much what happened this time, and still reading up on a lot of the radio astronomy, and trying to figure out which kits to start with, whether it's Radio Jovi or what's the other one, the Itsy Bitsy, I think. So last last online meeting, I said I was just getting started in this. I've got background in ham radio, but radio astronomy's always interested me, so I'm gonna keep reading more and listening to you guys because I listen and see all the presentations you guys do, and it's like I've got a lot to learn, but it looks like fun. So that's it for me.
Well, great. Yep. Glad you're here.
Here in Arizona, we were at 68%, and we were surprised. It actually did get a tad, I don't want to say darker, but yeah, towards the darker side. And we were surprised because we didn't expect to see any change at all, but it was just like a cloud cover came in and left pretty much as soon as it got there. But that was interesting. But I don't know whether the time of day had anything to do with it, because the eclipse that went through here was early. It was around 10 o'clock.
Nice. Okay.
Mm-hmm.
All right. Thanks, Helen. Don Latham. All right. Well, let me go to Roger Wood. All right. I guess we don't have those two. Anybody else I didn't get? Or anybody have any other things to bring up?
Sorry, this is Roger Wood. I was very late unmuting there.
Go ahead, Roger.
This is, I've joined just because of my curiosity. This group was recommended by a friend in Aptos here in California. And he set up a little receiver listening to Jim Creek and looking at the transmission from there. But I've enjoyed listening to all the presentations here. I am a radio ham, although I must admit I have not been active for several years now. But I'll chat with my friend Mike, and maybe we'll get a little bit more active. But thanks very much to everyone for letting me listen in. It's been very interesting. Thank you.
Well, thanks, Roger, and have Mike pop in too when he gets a chance. Okay. Let's see. Don, are you on yet?
Yeah.
Oh, there you go.
Not much to report for radio. Had a really good eclipse in mid-Ohio, Findlay, Ohio, with a friend of my son's. Drove 3 days, watched 3 minutes, drove 3 days. It was pretty interesting. This eclipse was, I think, my 13th or 14th. I can't remember. And an interesting one because of the activity. This time, there was red all the way around at one point, and the corona was unusually donut shaped. For most eclipses, there have been, it looks more spiky all the way around. This one was quite donut shaped and uniform. So the activity is real, and it showed up in the prominences and in the corona this time. There were only 2 sunspots from our point of view. One was very faint, and the other was pretty robust. So all the prominences that were seen and all the red that was seen were things on the approaching edge and the receding edge, and probably kind of around the corner, so to speak, on the sun. So it was very interesting, a very interesting eclipse, about average in length.
Don, I saw no prominences on the 17 total eclipse. A bunch
Right.
of, if not 3 or 4 this time. Is that
Right.
unusual?
No, that's usual. We're at the peak of
solar of of activity right now.
But
Those
for
are
totals.
yeah, those are active hams will know. Lots and lots of sunspots. Although this has been a very weird maximum. They're all weird. What am I saying? They're all noisy. But the 17 was on the approach to the maximum. So, and there were far fewer sunspots, and so you wouldn't see the prominences. The
So
sun's
prominence
been
are common to see with the total?
yes, yeah. If there are sunspots on the edge, uh, sort of on the edge of the sun, it's hard to put it. The sun, I've forgotten the average the rotation rate of the sun, but it's a few days. And the sunspots that are on the edges, then show the prominences when the moon obscures the sun. And also, it depends on the relative sizes of the sun and moon at the time, which varies from eclipse to eclipse. So some are almost total, some are almost annular, and others are very deep indeed. The Saros eclipses are can be 7 or 8 minutes long, which is absolutely fantastic to see. If you get a choice to see one eclipse, make sure it's a long one. So was unusual in that some of the photographs that I've seen show an almost complete ring of red on them. That's amazing, actually, quite amazing from an eclipse standpoint. And the uniformity of the corona is due to the fact that you were looking at the edges with lots of sunspots around. Usually, there's more toward the equator, and fewer on the poles. Although in the 17 eclipse, I think there was one pretty large one on the south. Well, the downward looking pole. I think it's the South Pole.
All right. Any questions for Don?
So seeing the red made me think of the story of the discovery of the element helium when they were doing an optical spectrograph of the chromosphere during a total eclipse in the late 19th century. So I was wondering, do you know what line that was that they?
Oh, the red that you see is hydrogen alpha.
Okay, that's what I thought. Okay.
Yeah, it's oh Lordy, I've forgotten the
653.
Yeah, something like that. Yeah, 653. Yeah, it's hydrogen alpha, definitely.
Okay.
The helium appeared and people didn't quite know what it was because at the
Mm-hmm.
time nobody had seen a helium line because from the Earth because, well, the only place helium was leaking out of some
Yeah.
very few oil wells at the time. Nobody even knew it was there.
Yeah, well, and I the way the story goes, that's why they named it helium, was because it was first found on the sun. And then it
Right.
was only less than 5 years later that Ernest Rutherford actually captured alpha decay or alpha particles and electrified it and proved that alpha particles were actually helium.
Yes, right.
So, do you know what color that line would have been? I'm not familiar with
Boy, I can't remember off the top of my head. No.
Yeah, I'm not familiar enough with it either, but Yeah, it just made me think of that, even
It's
though
such a hard, well, nowadays any good party balloon will give you helium, but it's if and as in terms of a naturally occurring spectrum, almost never seen on the Earth.
yeah, yeah,
As a gas, the argon and some of the other noble gases are normal in the atmosphere, very small traces, but they're there.
yeah,
But helium escapes almost immediately, and
yeah. Yeah, it's kind of mind blowing to think that all terrestrial helium is trapped alpha decay
yeah, right.
because all the primordial helium long left the planet, millions of years ago, probably
And
billions.
in the United States, the Navy used to own it all.
Of course they did.
Yeah, they used it for blimps
Yeah.
during World War II. The blimps post patrolled the coasts, east and west coast for submarines. I got to when I was a scout, a Sea Scout. We got a ride in a blimp, believe it or not, out
Wow.
of El Toro Air Station. They're all decommissioned now, but except for Goodyear and Fuji Chrome, I think. I don't even know if Fuji still has one or not, but Goodyear does.
That wasn't the Hindenburg, was it? You were trying to light a fire on it?
No, it wasn't the
Sea Scout? Just checking.
The blimp is not a dirigible. It's a gas
okay.
bag. The dirigibles, big ones, had a skeleton for a shape and separate gas bags in between several of them. But the blimp is just a big helium gas bag, and its shape is determined by its skin. By its skin. It's a lifting body, though. It has not only free lift, what's called free lift, which is what a round balloon has, like the Chinese balloons, or or they've been also used for lumberjacking, believe it or not. But due to its shape, the cigar shape has a good deal of lift due to the body shape itself.
Oh, okay.
While it's underway, it has or in the wind, tethered and in the wind, has quite a bit of lift. There are only some blimp-sized balloons that are up and down, and they're used for. They got radars on them, and they're used as a high altitude radar for catching dope smugglers. Now they've all been given to the from the Navy or from the Air Force. They were given to the dope guys. But I worked on one tethered balloon setup, which was set up in the Florida Keys because we had to put a radar on it because, while I was in Miami at the time, character flew in from Cuba with a MiG, and the first thing they knew he was there, he was requesting landing information for Homestead Air Base. He was defecting from the Cuban Air Force with a MiG. So they got all bothered. So they had radars on towers down in the Keys, but they weren't high enough in altitude to peek over the edge of the ocean. So for low altitude planes, so they put up these balloons at 10,000 feet, somewhere between 5,000 and 10,000 feet with radars on them. It was a sort of secret thing at the time. It isn't anymore. So now they just look for drug dealers. So if I were a drug dealer, I would observe the balloon, and when they pulled it down for maintenance, I'd fly over. You know, kind of
Okay.
Can I show Bob?
a very long history. I'm sorry. Yeah.
Can I show,
Go ahead.
can I show Bob one image, get his opinion of this? Let's see.
My opinion may be
No,
just that.
Bob was
Oh.
talking about Bob Strickland.
Well, Don knows a lot about this too.
See, I was thinking that if this was causing a shift in the frequency, I would see some vertical spikes in this. And I don't. I would think if the oscillator was changing, you would see this. Well, it's velocity, but it's frequency, that you would see this not being so nice and uniform. Yes, no?
And that's because it's over a long period of time, like several hours from one.
Well, yeah, this is 24 hours. This is 300 samples. And it is this data. What you see above is this is derived from here. This is all of the 300 samples. And what I did is, to accommodate all of this drift, I forced everything to be zero at a frequency that I picked. And then from here, I plot the data. But that's only an amplitude shift. This is LSR corrected also between here and there. But if this frequency was drifting, you would tend to see these spikes drift, and you would see, I would think, glitches this sharp in this span. This is 24 hours. This is 24 hours.
I don't think you would see sharp glitches. Possibly you would see.
Well, why wouldn't they be similar to this? This is the
frequency is going to be changing with temperature, so the sharpness of it will be dependent on how fast the temperature would be changing.
Right, but if it's changed this much, why wouldn't I see a shift in frequency here?
Well, maybe you are seeing one and you don't realize it.
Okay, then it's
So
negligible.
It's compared to the rest of, what you're looking, your lower image there is smooth.
Yeah. Well, these variations are a half. Okay, but let's quantify it. These variations are roughly a half dB peak to peak. This whole level is 1.5 dB.
Yeah.
So let's see. This is a half dB. So this is a half dB on that scale. If that was actually frequency, it should disturb that plot.
Well, you're telling us that the graph is intensity versus time, right?
This is velocity. This is velocity. The colors are intensity. This is velocity.
All right, so that's a spectrum change.
This is a vertical. The vertical is a spectrum. So I would think I would see some if I was actually shifting the local oscillator and my signal was changing in frequency, I would see some crazy excursions in this plot, vertical excursions.
Well, I would bet money that your LO is changing in frequency.
Okay.
It may be buried in your data where you can't really resolve it. When you said your spectrum was changing, that was the first.
It's changing in slope.
Mm-hmm.
So, well, it affects the amplitude, but
if your temperature stabilized your box, and you probably have stabilized your reference oscillator to some extent, it wouldn't be as good as a GPS discipline oscillator, probably still, but it's probably.
But if I stabilize the least effort would be to stabilize the temperature.
Yes. Okay.
I mean, that's the two resistors. That's the 10-cent solution versus getting a stable oscillator.
Sometimes when you do this with temperature though, too, if you look at your data hard enough, you can see your temperature stabilizing systems effects in the data. Also, when it turns on and warms up a little bit and turns off, you'll see that move up and down. I can see that in like in an HP reference oscillator that has temperature stability built into it. You can put that on a spectrum analyzer or a nice frequency monitor, and you can see that minor change from the temperature variation in the thing trying to stabilize it.
If you look,
many temperature stabilizing schemes are just bang bang, and it depends on the thermal behavior, first order filter kind of behavior on a essentially a switched on and off heat source or something like that. And you're right, Bob, those frequencies do appear sometimes in some data.
But that's why he has a heat sink in there as a damper.
That's
Yeah,
right.
you put in that damper as it's a first order filter,
if you
low pass.
if you look at this, if you can see where the cursor is, this is like overnight where the outside temperature is not changing. These little perturbations here are due to see, I'm externally controlling the heat to plus or minus 2 degrees C, 4 degrees Fahrenheit. This is the effect of that actually on the board itself, and it's pretty small. So it's better than it was.
I claim if Alex looks at the data from another day, it would look just the same on the vertical representation down below, showing that the effect is not from frequency changes. So I agree with Alex's understanding there.
And these wild perturbations are the sun sneaking around the piece of styrofoam that I had trying to keep the case cold. The case was getting hot. So these things here are the sun touching the case and heating it up. So, well, whatever. At least I have identified what has always been a mystery to me, is why all of my plots have more or less look like this. And it's the heat variation on of the SDR. End of story.
All right. Anybody have any questions for Alex? Good discussion. Okay. Well, that's all we got for today. Thanks, everybody, and I'll get this posted.